Hello friends, I hope you are all fine. In this video, we shall discuss about the answers of the Part A MCQ that appeared in the second PUC annual examination question paper this March 2023. We shall take the first question. Which kind of defect is introduced by doping the semiconductor? A. Dislocation defect. B. Electronic defect. C. Interstitial defect. D. Schottky defect. Dear friends, when the extrinsic semiconductor is doped with the suitable element, either N type of semiconductor or P type of the semiconductor is formed depending upon the nature of the impurity that we are going to add or nature of the element that is going to be added to the extrinsic semiconductor. So here the correct option is the B option, that is electronic effect. Question number 2. A binary liquid mixture that forms maximum boiling isotropic at a specific composition is A. Ethanol plus water, B. N-hexane plus N-heptane, C. Benzene plus toluene, D. Nitric acid plus water. Dear friends, the correct option is the D option, that is nitric acid plus water. Now this is the non-ideal solution mixture that forms the maximum boiling isotropic mixture. Now here isotropic mixture is one which boils with uniform composition at constant temperature. Now here the first option, ethanol and water, is the isotropic mixture that shows the minimum boiling isotropic mixture. The second option, N-hexane plus N-heptane, and the third option, benzene plus toluene, these two are the ideal solutions. So the correct option is the last option, nitric acid plus water mixture. It forms the maximum boiling isotropic mixture. Question number 3. The value of Van't-Hoff factor I for ethanoic acid in benzene is nearly A 2, B 1, C 0.5 and D 0. Dear friends, for the solute which undergoes association, the Van't-Hoff factor will be less than 1, and for the solute which undergoes dissociation, the Van't-Hoff factor will be more than 1. So here the ethanoic acid undergoes association in benzene, therefore the Van't-Hoff factor I is less than 1, that is 0.5. So that is a correct option, C option, 0.5. Let us take question number 4. On charging the lead storage battery, PbSO4 on the cathode is converted to A PbO2, B Pb, C PbO, and D no change. Dear friends, when the lead storage battery is under the process of charging, the following reaction will take place and it will be converted to PbO2 at the cathode. PbSO4 plus 2H2O gives PbO2 plus 4H plus SO4 2 minus plus 4 electron. So the correct option is PbO2. Here in the lead storage battery, the anode is lead and the cathode is a grid of lead that is packed with lead dioxide, and whatever the reactions are taking place during discharging, they will be reversed during the charging. Now here at the cathode, this reaction will take place so that the PbSO4 will be converted to PbO2 by losing the electron. So the correct option is A option, that is PbO2. Let us take question number 5. In the Arrhenius equation, the factor e to the power of minus Ea divided by RT corresponds to A. Collision frequency, B. Proper orientation. C. Fraction of molecules with the kinetic energy more than EA. D. Threshold energy. Difference in the given expression e to the power of minus A by RT. EA is the energy of activation, R is the universal gas constant, T is the temperature. So here first option is a collision frequency, that is not in the expression, and second option proper orientation P, that is also not in the expression. The only thing is the third option, that is a fraction of molecules with the kinetic energy greater than EA is what is represented by the given expression. Therefore the correct option is C option, the fraction of molecules with the kinetic energy more than EA. Difference, let us take question number 6. Which of the following is not applicable to the phenomena of adsorption? Here are the options. A. Delta G equal to negative. B. Delta S equal to negative. C. Delta H equal to negative. D. Delta H equal to positive. Difference, the adsorption process is the process in which the accumulation of the substance is more on the surface than into the bulk of the substance, and this adsorption process is a spontaneous process. It is a exothermic process, that means heat is liberated in this process, and it is accompanied by a decrease in entropy. Therefore, so for this process delta G is negative, delta S is negative, and delta H is also negative. Therefore the correct option is the last option, that is D option, delta H equal to positive, because it is not endothermic process. For endothermic process delta H is positive, for exothermic process delta H is negative. So the correct option is the D option. Next, question number 7. The role of NaCN in the separation of PBS from ZNS by a froth flotation is A. Depressant, B. Froth stabilizer, C. Collector, and D. Reductant. Difference, in this process NaCN is used as a depressant in the separation of PBS from ZNS by a froth flotation process. So a depressant is one which selectively allows only one particular type of the ore to form the froth. So here NaCN allows only PBS to form the froth but not ZNS, so it is used as a depressant. So the correct option is A option, that is a depressant. Let us take question number 8. On complete hydrolysis of xenon hexafluoride with water, that is XeF6 with water, the product formed is A. XeF4, B. XeO3, C. XeO2F2, D. XeOF4. Difference, this reaction will take place during the hydrolysis of XeF6. You can see the equation here. XeO3 is formed as the product. Therefore the correct option is the B option, that is XeO3. Let us take question number 9. Which of the following elements is not regarded as a transition element? Here are the options. A. Fe, B. Mn, C. Sc, D. Zn. Different, the correct option is the D option, that is Zn. So Zn contains the completely filled d orbitals. So it is not regarded as a transition element, but it is placed in the D block along with the other transition elements. Whereas in all the other three options, Fe, Mn, and Sc, the d orbital is not completely filled. Whereas only in the Zn it is having completely filled d orbitals. So there is a correct option. Let us take question number 10. MC bond in metal carbonyls possesses dash. A. Ionic character, B. both sigma and pi character, C. only pi character, and D. ion dipole force. Different, the correct option is the second option, that is both sigma and pi character, that is possessed by the MC bond in metal carbonyl. Let us take question number 11. Identify the compound containing chiral molecule. A. 2-bromobutane, B. 1-bromobutane, C. 2-bromopropane, D. 2-bromo-2-methylpropane. Dear friends, the correct option is the first option, that is A. 2-bromobutane. That is a compound which contains one chiral carbon atom. So a chiral carbon atom is one which is attached to 4 different atoms or group of atoms. So in the 2-bromobutane, the second carbon atom is the chiral carbon atom, and to this carbon atom you have one bromine, one hydrogen, one methyl and other ethyl group. So that is the one which contains the chiral carbon atom. So there is a correct option, the A option. Question number 12. When CH3ONA react with CH3 thrice CBr, the product formed is A. T-butyl methyl ether, that is a tertiary butyl methyl ether, B. 2,2-dimethylpropane, C. 2-methylpropene, D. 2-methylpropanol, that is a 2-methylpropane-2-ol. Difference here, it is the third option, that is the correct option, C option. 2-methylpropene is the correct option, because here the tertiary haloalkane is reacting with the sodium methoxide. So if the haloalkane is tertiary and the sodium alkoxide is the alkoxide of the primary alcohol, then it leads to a formation of the alkene. Elimination will take place, not the substitution. If it is the primary haloalkane and the sodium alkoxide of the tertiary hydrocarbon group, then it will form the ether, but here it is the opposite one, that is a tertiary haloalkane reacting with the sodium alkoxide of the primary alcohol. Therefore the alkene is formed in this. So the alkene formed is 2-methylpropene, that is a correct option. Let us take question number 13. Iodoform reaction with NaOI can be used for detection of the compound A. C2H5CO C2H5, B. CH3CHO, C. CH3CH2 CH2OH, D. CH3 twice COH. Dear friends, this iodoform reaction with NaOI can be used for detection of the CH3CO group in the compound. Therefore it is the second option, that is CH3CHO, that contains the CH3CO group. So the correct option is the B option, that is CH3CHO. Question number 14. Nitration of aniline in strongly acidic medium at 288 Kelvin yields A. 2,4,6-trinitroaniline, B. O and para-nitroaniline, O and P, that is ortho and para-nitroaniline, C. M-nitroaniline, that is meta-nitroaniline, D. OP and M-nitroaniline, that is ortho, para and meta-nitroaniline. So dear friends, the correct option is the D option, OP and M-meta-nitroaniline. Here in this aniline, NH2 group is the ortho-para directing group, but in strongly acidic medium, anilinium ion is formed, so that will be meta-directing. So in addition to ortho and para, meta-nitroaniline is also formed. Therefore the correct option is OP and M-nitroaniline. Let us take question number 15. Which of the following hormones contain iodine? Here are the options: A. Insulin, B. Epinephrine, C. Thyroxine, D. Glucagon. Dear friends, the correct option is the C option, that is a thyroxine. So that is the C option, thyroxine, that contains iodine. So dear friends, thank you very much for being with me in the discussion of these questions. Wish you all the best of luck.